In this video, I'll be going through the 2021 May-June A-Level Physics multiple choice paper. What is a reasonable estimate of the volume of an adult person? If we were to consider an adult person, to estimate the volume, we need to estimate the three dimensions. We can imagine most of our mass is going to be concentrated within a height of about a meter, assume a depth of around 0.2 meters, and a reasonable width would be about 0.5 meters. Multiplying these together gives me 0.1 meter cube, which by an honest coincidence is our answer A, but with any set of reasonable numbers you should land in this ballpark. Which combination of units could be used for expressing the power dissipated in a resistor? If we consider that power is work over time, and also that work is force times distance, our units of force is a newton, our unit of distance is a meter, and our unit of time is seconds, which is to the power of -1 because it's in the denominator, giving us our answer D. A force of 10 newtons and a force of 5 newtons act on an object. The angle between the forces is 150 degrees. The resultant force on the object can be resolved into a pair of perpendicular components. Which row shows numerical expressions for a possible pair of perpendicular components? If we consider our x-axis in this direction and our y in this direction here, we can separate our 5 newtons into an x and y component, knowing that this is a right-angled triangle, where our angle here is 30 degrees. Because our 150 degrees plus whatever this angle is must add to 180. Using trigonometry, we can show that this side here must be 5 cosine 30, and this side must be 5 sine 30. Therefore, for our x component, our 10 newtons has no component in the x direction, so this is just 5 sine 30. For our y, however, this is going to be our 10 newtons minus our 5 cosine 30, which happens to be this answer here. A signal of frequency 25 Hz is displayed on the screen of a cathode ray oscilloscope. What is the time-based setting? If we have a frequency of 25 Hz, our period is going to be 1/25, which gives me 0.04 seconds. That means that our full wavelength here must be 0.04, and therefore one increment is going to be 0.02 seconds, or in other words, 20 milliseconds. A micrometer screw gauge is used to measure the diameter of a wire. The reading on the micrometer with the jaws closed is -0.05 plus or minus 0.02 mm. The reading on the wire in position between the two jaws is +1.03 plus or minus 0.02 mm. What is the diameter of the wire? If the reading on the micrometer with the jaws closed is -0.05, then we need to add 0.05 to our subsequent reading, which gives me 1.08. When you add two numbers, you sum together their absolute uncertainty. So our uncertainty must be 0.04. Our answer is therefore D. A projectile is launched at an angle to the horizontal at time equals 0. It travels over horizontal ground as shown. Air resistance is negligible. Which graph best shows the variation with t of the speed of the projectile from when it is launched to when it lands on the ground? First of all, the speed is not going to go to 0 because we're always going to have a horizontal speed. So it's not these two. We also know that our speed is going to change. It will definitely not remain constant, leaving us with C. A train initially at rest at a station has a uniform acceleration of 0.2 meters per second until it reaches a speed of 20 meters per second. It travels for a time at this constant speed and then has a uniform deceleration of 0.4 meters per second until it comes to a rest at the next station. The distance between the two stations is 3,000 meters. What is the time taken by the train to travel between the two stations? What we have is three separate sections of motion. We have a period of acceleration, a period of constant speed, and a period of deceleration to rest. I'm going to call these A, B, and C. Now finding the time for our acceleration and deceleration periods is going to be quite straightforward. However, for our section B, although we know the speed, we don't know the distance. So our first step is going to be to figure out the distance, which requires us to find the distance for A and C. Now we know the equation v squared equals u squared plus 2as. For our section A, our initial velocity is 0, so we can ignore our u and write v squared equals 2as. Solving this for our distance s by dividing both sides by 2a and swapping them around. Putting our numbers in gives me 1,000 meters. We can use the same equation for our section C, except now we have an acceleration of 0.4, which gives me 500 meters. Now we know the distance for our section B must be our total distance of 3,000 minus the distances of A and C, which gives me 1,500 meters. Now we can find our times. For this we can use the equation s equals ut plus half at squared, where for our section A our u is 0, so we can just write s equals half at squared, solving this for time by multiplying both sides by 2, dividing by a and square rooting. Putting our numbers in gives me 100 seconds. Using the same equation for C gives me 50 seconds. Finally, for our section B, because we have no acceleration, we can just use the equation v equals s over t. We're solving for t, this gives us s over v, where our distance is 1500 and our velocity is 20, which gives me 75 seconds. Adding these all together to find our total time gives me 225 seconds, which rounds up to 230. A rocket is fired from Earth into space. Newton's third law of motion describes how forces act in pairs. One of the forces of a pair is the weight of the rocket. What is the other force of this pair? Just as Earth exerts a gravitational force on the rocket exerts an equal and opposite gravitational force on the Earth. The graph shows how quantity P varies with quantity Q for a body falling vertically downwards in a uniform gravitational field with air resistance. Which pair of quantities could be represented by P and Q? And so we see as Q increases, our P decreases. The overarching topic here is terminal velocity, which describes that as our velocity of our falling body increases, our force of air resistance also increases, which counteracts our gravitational force and makes the net force decrease, which means our acceleration must decrease. And so if our acceleration decreases, we know that our force of air resistance must increase, which fits our observed pattern of P and Q. So our answer is A. Which quantities are conserved in an inelastic collision? Kinetic energy is not, total energy is, and linear momentum is. So our answer is C. A charged oil drop is held stationary between two charged plates. Which forces act on the oil drop? We have the gravitational force, as well as the electric force from our plates, and so the answer is A, both electric and gravitational. Which pair of forces forms a couple with a torque of 30 Newton meters? For A, if we take our pivot here, our distances to each is 1 meter. Adding our force times distances gives us 60, so it's not A. Taking our pivot in the middle here, that means our distance must be 0.5, and our forces oppose each other, so we'll make this one negative. Adding our force times distances, which gives me 15, so it's not this one either. Taking our pivot here, our distance is once again 0.5. Our torques are in the same direction, so we can add our force times distances, which gives me 15, so it's not this one either. Taking our pivot here, our distance is 1 meter. Our torques are in the same direction, so we can add our force times distances, which finally gives us 30. So our answer is D. A uniform rigid bar XZ with negligible mass is 1.2 meters long. The bar is pivoted at point P. 3 coplanar forces act on the bar as shown. Forces of 16 and 20 newtons act perpendicularly to the bar at points X and Y respectively. Force F acts at point Z at an angle of 30 degrees to the axis of the bar. The distances along the bar of the pivot and of the forces are shown. The bar experiences a resultant moment about point P of 6 Newton meters in a clockwise direction. What is the magnitude of F? Our force F is going to exert a torque from its component perpendicular to the bar. Using trigonometry and noting that this is the opposite side, we can get our force as F sine 30, adding our torques up, making our clockwise ones positive, and our counterclockwise one negative. We have our force of 16 times 0.3, minus our force of 20 times 0.3, plus our force F sine 30, multiplied by the distance of 0.6 plus 0.3, which gives us 0.9. All of that adds up to our resultant moment, which is 6 Newton meters, and because it's in a clockwise direction and we chose to make clockwise positive, it must be positive 6. Solving that for F by subtracting these two terms from both sides, and now dividing both sides by 0.9 sine 30, which gives me 16 newtons, so our answer must be C. Water of depth 0.9 centimeters is covered by oil of depth 5 centimeters in a measuring cylinder. The density of water is 1000 kg/meter per cube, and the density of oil is 800 kilograms per meter cube. What is the total pressure exerted on the base of the measuring cylinder due to the oil and water? Our equation for our hydrostatic pressure is density times gravity times height, which for our water is 1000 times our 9.8 times our depth of 9 centimeters, which is 0.09 meters. For our oil, that is 800 times our 9.8 once again, times our depth of 5 centimeters, which is 0.05 meters, which gives me 1300 pascals, so our answer must be D. A rocket is fired upwards as it accelerates upwards after leaving the launch pad. Which forms of energy are changing? It's using fuel, so its chemical energy is changing. It's performing work against gravity, so its gravitational potential energy is increasing. And it's accelerating upwards, so it's gaining velocity, which means its kinetic energy must be increasing. Therefore, all three are changing, and therefore our answer must be A. A roll of tape of length 50 meters requires a constant force of 20 newtons to unwrap it. What is the work done in unwrapping the whole roll? Work is force times distance, our force is 20, and our distance is 50, which gives us 1000 joules, so our answer must be D. A trolley of mass 600 kilograms is initially at point P on a slope, at a height of 80 meters above ground level, as shown. The trolley is released from rest and moves along the slope, first coming to rest at point Q, at height h above ground level. The total distance PQ moved by the trolley along the slope is 1.5 kilometers. A constant resistive force of 300 newtons opposes the motion of the trolley on the slope. What is h? We can consider the energy before and after. Our energy before is just our gravitational potential energy, which is our mass times our gravitational acceleration, multiplied by our height of 80. Afterwards, we're also going to have a gravitational potential energy, this time with a height of h, which we're trying to find. We will also have lost some energy to our constant resistive force. The amount of energy lost is our work done, which is given by force times distance, where our force is 300 and our distance is 1.5 kilometers, which is 1500 meters. Solving this for h by subtracting this term here from both sides and dividing by mg, and also swapping them around. Putting our numbers in gives me 3.5 meters to two significant figures, so our answer must be A. An object of weight 15 newtons is pulled along a horizontal surface at a constant velocity of 2 meters per second. The force pulling the object is 12 newtons at 30 degrees to the horizontal as shown. What is the power used to move the object? Our power is our work divided by time, where our work is our force times distance. Our distance per time is our velocity, and the component of our 12 newtons in the direction of our motion is 12 cosine 30. Putting those numbers in gives me 20.8 watts, so our answer is B. The spring constants of four springs are determined by plotting the following graphs of force. Which order of the graphs shows decreasing spring constants? You might recall that F is equal to Kx, and so our spring constant K is going to be force divided by X. Here that is 10 divided by 5, which gives us 2. Here that is 20 divided by 4, which gives us 5. Here that is 100 divided by 0.1, which gives us 1000. And over here, that is 10 divided by 0.5, which gives us 20. So from largest to smallest, that is 3, 4, 2, and 1. So our answer is B. Forces are applied to the ends of a rod so that its length increases. The variation with force F of the extension E of the rod is shown. The point P is the elastic limit, which shaded area represents the work done during the plastic deformation of the rod. Plastic deformation is occurring in this section here. Our work done is going to be the force over that distance, which is this distance here, not the entire distance as indicated in these three. Our answer is therefore C. Two identical waves are produced by the sources at point P and Q. The waves travel along different paths to reach point R as shown. Both waves have a wavelength of 6 cm. The waves are in phase at point R. What is the phase difference between the waves as they leave point P and Q? Our path difference is 20 cm, which, because our wavelength is 6, is 3 wavelengths plus a third of a wavelength. Because 3 wavelengths is 18, and a third of a wavelength is 2, giving us our total path difference of 20. And so our phase difference is 1/3 of a wavelength, and therefore 1/3 of 360 degrees, which is 120 degrees. So our answer is D. A longitudinal wave travelling from left to right has vibrations parallel to the direction of transfer of energy by the wave. The wave can be represented on a graph showing the variation with the distance of the displacement of the particles from their equilibrium position at one instant. Which point on the graph is the centre of a compression? At point A we have displacement to the right, at point B we have no displacement, at point C we have displacement to the left, and at point D we have no displacement. If we were to imagine a point up here, we would have displacement to the right, and as you can hopefully see with A going this way and C going this way, B is at a centre of a compression, whereas with D we have C going away and the top here going away, meaning that D is the centre of a rarefaction. So our answer is B. A stationary wave is formed from 2 identical sound waves. A microphone is placed at a position of maximum loudness. It is then moved along the stationary wave from this first position of maximum loudness to the 4th position of maximum loudness. The microphone moves a distance of 12 cm. The speed of sound is 330 meters per second. If we imagine a standing wave pattern, imagine a position of maximum loudness. Our next loud spot is here, the next one is here, and our 4th one is here. We have 1 wavelength here, and half of a wavelength here. That means that our 12 centimeters is 1.5 wavelengths. Solving that for wavelength gives me 8 centimeters, or 0.08 meters. We know that velocity is frequency times wavelength. Rearranging for frequency gives us velocity over wavelength. Our velocity is 330, and our wavelength is 0.08, which gives me 4125 Hz, so our answer is A. An ambulance has a siren that emits sound of a constant frequency. The ambulance is moving directly towards a stationary observer. The ambulance decelerates as it is approaching the observer, and then accelerates as it has passed the observer. How does the frequency of the sound heard by the observer change as the ambulance is approaching and as it is moving away from the observer? As the ambulance is approaching, it is decelerating, which if we graph the frequency and have the true frequency here, and put the observer here, our observer is going to observe an increased frequency, but because the ambulance is decelerating, the Doppler shift is going to be decreasing, and therefore the frequency is going to be decreasing. Now, as the ambulance is moving away, it accelerates, which means its velocity away is going to be increasing, and our Doppler shift is going to be increasing as well, which means our frequency is also going to be decreasing. So our answer is A. Microwaves in a vacuum travel at speed x and have a wavelength of order of magnitude y. What are the speed and a possible order of magnitude of wavelength of X-rays in a vacuum? The speed is going to be the same because they're both electromagnetic radiation that travel at 3 times 10 to the 8, and we'd expect a wavelength much more in the ballpark of 10 to the minus 8 than we would 10 to the minus 4. Our answer must therefore be A. The diagram shows part of a stationary wave on a string. X and Y are points on the string. The vibrations at X and Y are 180 degrees out of phase. What is the distance between X and Y? Our full wavelength is our peak to peak, and our distance between X and Y is precisely half of this. Our answer is therefore B. Which wave behavior is shown in the diagram? This is diffraction. A teacher sets up the apparatus shown to demonstrate a double-slit interference pattern on a screen. Which change to the apparatus will increase the fringe spacing? The distance P will have no effect. Decreasing the distance Q will increase the fringe spacing, so our answer should be B. Double checking the other things. Decreasing the distance R will actually decrease our fringe spacing, since if we imagine our fringes like this, moving our screen over to here for example, we'll see a reduced fringe spacing. And decreasing the wavelength of light will also in fact decrease our fringe spacing, so our answer must be B. Light of a single unknown wavelength and blue light of a single wavelength are both incident normally on a diffraction grating. 2 diffraction patterns are produced, one for each wavelength of light. The third order maximum for the blue light occurs at the same angle as the second order maximum for the light of unknown wavelength. The wavelength of the blue light is 480 nanometers. What is the unknown wavelength? Because the path difference to this point must be the same, since our slit separation hasn't changed and we have the same angle, their n times lambdas must be equal. Our n for our blue light is 3, and our wavelength is 480. Our n for our unknown light is 2, and our lambda is what we're trying to find. Solving this for lambda by dividing both sides by 2 gives me 720 nanometers, so our answer must be B. What is the electric field strength in a region where a proton accelerates at 2 meters per second due to the field? Our electric force is our E times our Q, where our force is our mass times acceleration. We're given the mass and the charge at the front of the booklet, and we know our acceleration is 2, so we need to solve for our electric field strength E. We can do that by dividing both sides by Q, and now put our numbers in. The rest mass of a proton at the front of the booklet is given as 1.67 times 10 to the minus 27. Our acceleration is 2, and the charge of a proton is our elementary charge, which at the front of the booklet is 1.6 times 10 to the minus 19, which gives me 2.09 times 10 to the minus 8 volts per meter, 3 significant figures, which can also be written as 20.9 nanovolts per meter, so our answer is D. An oil drop of mass 2.6 times 10 to the minus 15 kilograms, and with a charge of negative 4.8 times 10 to the minus 19 coulombs, is in a vacuum between 2 horizontal plates. The plates have a separation of 2 centimeters and a potential difference between them of 1200 volts, as shown. Which statement describes the motion of the oil drop? We know that the electric force is given by EQ, and force is equal to mass times acceleration. Therefore, the acceleration from our electric force is going to be EQ divided by m. Now we also know that the electric field strength is voltage divided by distance, so we can make that substitution. The total acceleration of our oil drop is going to be this acceleration minus the acceleration due to gravity. We know the voltage, we know the charge, we know the distance, we know the mass, and we know the acceleration due to gravity. Putting those numbers in gives me 1.3 meters per second to 2 significant figures, so our answer is C. Which 2 units are used to define the coulomb? An ampere is a coulomb per second, and if we multiply that by a second, the seconds cancel, and we get a coulomb, so our answer must be A. A mobile phone battery is charged by connecting it to a constant potential difference of 5 volts. After a time of 1 hour, the initial current of 0.5 amps slowly decreases to 0 as shown. What is the best estimate of the energy transferred to the battery during the time of 2 hours shown in the graph? Recall that power is energy per time, so energy is power multiplied by time. Power is voltage times current, Current times time is just charge. Where we know our voltage, but we don't know our charge. But because we have our current here and our time here, current times time gives us our charge, and so our charge must be the area underneath this graph, which is going to be 0.5, our current, multiplied by 1 hour in seconds, plus this area here, which is this area here divided by 2. Which gives me 2,700 coulombs. Putting that into our equation over here, gives me 13,500 joules, which is 14,000 to two significant figures, so our answer must be C. A length of wire is connected in an electric circuit. The current in the wire is measured, which change on its own could increase the current in the wire. An increase in the length of the wire is going to increase resistance and decrease our current, so it's not A. An increase in the radius of the wire is going to decrease the resistance, so it will increase our current, so it looks like our answer is B. An increase in the resistance of the wire will decrease our current, so it's not C, as will an increase in the resistivity of the wire, so our answer is indeed B. A cell is described as having an electromotive force of 6 volts. What does this mean? A coulomb of charge always dissipates 6 joules of energy in the internal resistance of the cell. EMF does not take into account internal resistance, so it's not A. One electron gains 6 joules of energy when passing through the cell. Because volts is energy per coulomb, not energy per electron, it's not B. There is a potential difference of 6 volts applied across any external circuit connected to the cell. This is not the case because the internal resistance is going to result in a decreased voltage across the cell overall. When 1 coulomb of charge passes through the cell, 6 joules of chemical energy is transformed, which is a sensible statement, so our answer is D. The diagram shows a network of resistors. Each resistor has a resistance R. What is the total resistance of the network between points X and Y? Our resistance is going to be these 3 in series, so that's going to be R plus 1 over 1 over R plus 1 over R plus 1 over 1 over R plus 1 over R plus 1 over R, which we can simplify into R plus 1 over 2 over R plus 1 over 3 over R. Simplifying that further, because our R is a denominator in a denominator, it becomes a numerator. Adding these 3 terms together by giving them all a denominator of 6, imagining R as R over 1 and multiplying the top and bottom by 6. Multiplying the top and bottom of R over 2 by 3 to turn it into 3R over 6, and multiplying the top and bottom of R over 3 by 2 to get 2R over 6. Adding those together gives us 11R over 6, and so our answer is C. 3 resistors are connected in series with a battery as shown. The battery has negligible internal resistance. What is the potential difference across the 180 ohm resistor? To find the potential difference, we need to know the current, where we know that V is equal to IR, where our supply voltage of 6 is equal to our current multiplied by the total resistance, which is our resistors summed together because they are in series. Which gives us 6 equals I times 450. Which means that I is equal to 6 over 450, or 0.0133 amps. Once again using V equals IR, this time with our current of 0.0133 and our resistance of 180, gives me 2.4 volts, so our answer must be B. A potentiometer circuit is used to determine the unknown electromotive force of a cell. A potentiometer circuit is used to determine the unknown electromotive force of a cell X. In the circuit shown, E is a cell with an EMF that is known accurately. QR is the potentiometer wire, which has a movable contact S. Contact S is connected to a galvanometer and to cell X. What is not a necessary requirement to determine the EMF of X from the circuit? And so the idea is, in order to find our value of X, we take E, which must be of a higher voltage, and we increase the value of our potentiometer until our current becomes 0. and so the EMF of cell X must indeed be lower than the EMF of cell E. The internal resistance doesn't need to be known because the current is zero, so therefore it consumes no voltage. The lengths QS and QR must be determined accurately, they do, and the resistance of the wire QR must be proportional to its length, also must be true. So our answer is B. A nucleus of uranium-235 undergoes a series of decays. During the series of decays, 2 alpha particles and 1 beta particle are emitted. As a result, a nucleus of actinium Ac is formed. What is the correct notation for the nuclide of actinium that is formed? And so if our 235 uranium decays into 2 alpha particles and 1 beta particle, plus our actinium of unknown value, to balance our atomic mass, our alpha particles carry away 8, therefore our atomic mass must be 235 minus 8, or 227. As for the atomic number, our alpha particles carry away 4, and our beta particle carries away -1, which means our atomic number must decrease by 3, to give us 89. Our answer is therefore B. Which particle is a fundamental particle? Which is the electron? And we're done.